Designing a cable railing system is easy when you incorporate some design considerations that apply to cable railings. In the next few minutes, we'll discuss how to construct the railing to support the load of the cables when they're tensioned, the spacing of the cables so they'll conform to building codes, and the hardware options available for cable tensioning. To meet most building code requirements, cables must be tensioned enough to prevent a 4-inch sphere from penetrating the cables at any point. The following guidelines address the need to properly tension the cables while minimizing any obstruction on the view through the railing. We recommend a railing frame that will support at least 400 pounds of tension per cable. The frame itself needs to be burly enough to handle the tension, otherwise the members acting as end posts may bow. Your cables should be spaced so there is approximately 3 inches on center between the cables. And the cable should be vertically supported by some method every 42 inches or less along the cable run to help keep the cables from allowing a 4-inch sphere to penetrate them. Intermediate supports can be low profile, such as 1/4 inch thick by 1 inch wide flat bar. 400 pounds of tension per cable, 3-inch spacing between cables, vertical supports every 42 inches max. Follow these guidelines and you'll be able to build a cable railing that will meet code requirements, will highlight your view, and stand proudly for years. Drawings are available for 3 different styles of metal railings that will meet code requirements when our cable spacing recommendations are followed. One is a double end post construction using 2 1x rectangular tubes with 1/8 inch walls separated by stainless steel spacers. The spacers integrate with the structure of the system to create a strong end post. Because the 2 posts are only 1 inch wide, there is little visual obstruction created by the railing frame. It can be fabricated from carbon steel or stainless steel. Here is a 2x2 square steel end post with a 1/4 inch wall. Using less than a 1/4 inch wall on the end posts can result in bowing of the posts. Since there is no tension on intermediate posts, opting for a thinner wall, typically 1/8 inch, is fine for cable railing systems. Again, the posts can be fabricated from carbon or stainless steel. Cable railings can be fabricated using round tubing or pipe. End posts to which fittings are attached need to be a minimum Schedule 80 pipe or round tubing with a comparable wall thickness. Like with thinner intermediate square tube posts, Schedule 40 pipe is commonly used for intermediates. It can be good for top and bottom rail too. For corners, you might want to attach tubes to corner posts through which the cables run. They look great and allow you to run cables through more corners than you can otherwise. This reduces the number of fittings you need compared to terminating your cable runs at every corner. Corner tubes require the cables to be swedged on site, which you would want to do anyway if you're going through several turns. Vertically run cables can be used where codes do not permit horizontally run cables, or if that's your preference anyway. Because there are more assemblies, a vertical system is more costly than a horizontal one. Metal frames can be made of carbon steel or stainless in pipe, round tubing, or square or rectangular tubing. Stainless steel is strongly recommended for exterior applications because moisture will get inside tubing through the holes used to mount the fittings. You aren't limited to the pre-designed railing styles we've shown you. You can use your own unique design as long as it meets the load requirements we've discussed earlier. Here are some examples of uniquely designed cable railings. Aluminum frames using off-the-shelf tubing may not have sufficient strength to support the tension of the cables. Special extrusions or reinforced end posts should be considered. You should confirm that the end posts you use will support the tension of the cables before using an aluminum frame. We know of no vinyl or composite materials that will support the tension of the cables required to meet most building codes. Cables should be attached to wood or metal posts inside vinyl or composite sleeves that cover the posts. In areas where there are large temperature variations, attention needs to be paid to temperature changes that can affect cable tension. The larger the cable diameter, and the greater the distance between terminating end posts, the greater the effect of temperature changes. Once you've installed the cables, this chart shows the temperature increase necessary for the cables to lose sufficient tension and fall below code requirements. The larger the diameter of the cable, and the farther the distance between terminating end posts, the greater the thermal effect. The same basic design elements apply to wood-framed railings that apply to metal. Cable tensioning and spacing are the same. We recommend a minimum standard 4x4 for terminating end posts where fittings will be attached. Type of wood is not so important. Attention must be paid to supporting the top rail so it won't bend when the tension of the cables is applied to the terminating end posts. When the cables are tensioned, force is applied to the bottom of the end posts where they mount to the deck or other floor surface. The post must be mounted in a manner that will support the load applied at the floor. An alternative is to use a bottom rail running between the terminating end posts that will take the load off the bottom of the end post. We recommend that cables be tensioned to 400 pounds per cable. There should be a free opening between cables of approximately 3 inches. And the cable should be supported in some manner no more than every 42 inches along the cable run. When deciding what cable to use, we recommend a Type 316 stainless steel cable with a 1x19 construction. This cable is highly corrosion resistant, rigid, and will not stretch under load as other types will. It also has a higher breaking strength than other constructions, such as 7x7 or 7x19. Ultra-tec fittings are designed for left-hand lay cable. How big a cable you use depends on 2 things: where it's being used and aesthetics. The larger the diameter of the cable, the higher its breaking strength. 1/8 inch diameter cable can be used where there's little or no pedestrian traffic or where the railing does not need to meet code requirements. It's acceptable for most single-family homes. It's also satisfactory for use with vertically run cables because vertical runs are not as susceptible to shock loads as horizontally run cables. 3/16 inch cable is the most commonly used for pedestrian railings. It has a much higher breaking strength than 1/8 inch cable, yet is thin enough that it doesn't interfere with the view. Because it has an even higher breaking strength, 1/4 inch or larger diameter cable is recommended for use in high-traffic public areas where the railing can be subject to abuse. 5/16 inch and 3/8 inch cable are not used nearly as frequently as the smaller diameters because they're thicker, can interfere with the view, and are considerably more expensive than the smaller cables. These sizes are normally used where a larger cable is desired from an aesthetic standpoint, where a heavy look is desired. So far, so good, but it's important to select the right tensioning and mounting hardware for your cable railing. In the past, you had to choose from cable turnbuckles and fittings that were designed for marine or industrial uses. They were often bulky, unattractive, and sometimes had exposed cable ends that could scratch skin or catch a piece of clothing. Many were easy to tamper with, so they weren't really suitable for high-traffic public areas. Now, you have modern, sleek, all stainless steel tensioning and mounting devices to choose from. No unsightly turnbuckles, exposed nuts, or loose cable ends. With Ultra-tec hardware, you can choose fittings that are hidden inside the terminating end posts. There is nothing to interfere with the view. Invisware receivers replace bulky turnbuckles. They fit inside the end post and are tensioned with a hex wrench. Simple, easy, and all you see is cable. And because they're hidden inside the post, they're highly tamper resistant. Push and pull lock fittings can be installed by hand at the job site. Most can be hidden inside the post, so they are highly tamper resistant. No special equipment is needed. Simple, easy, and all you see is cable. There are also tensioners to replace turnbuckles that mount to the outside of the post. Sleek, stainless steel, all easy to install, are designed to be tamper resistant and look great when you're finished.